Hello and welcome to today's webinar, AI Infrastructure from Planning to Conquering. Today's event is brought to you by Pure Storage, NVIDIA, and Core Scientific. My name is David Davis of Actual Tech Media, and I'm excited to be your moderator for today's event. Before I introduce you to today's expert presenters, I want to first remind you that we want this to be an educational event. So we encourage you to use the questions box there in the GoToWebinar control panel. We'll be available to answer questions throughout the event, and then we'll also have a dedicated Q&A session at the end of the event where we will be taking the best questions live. So make sure you get your questions in early. We have expert presenters available, like I said, to answer those questions throughout the event. I'll also be announcing one prize winner on today's live event for the Amazon $300 gift card. That gift card, if you're watching this event on demand, I'm sorry, the drawing has already occurred. Prize terms and conditions can be found at events.actualtechmedia.com. And with that, I'm excited to introduce you to today's three expert presenters. We have a great panel lined up for you. First off, you'll hear from Tony Pikeday, who is Director of AI Systems at NVIDIA. After that, you'll hear from Bish Mishra, Senior Product Marketing Manager for FLASHBLADE at Pure Storage. And finally, Ian Ferreira, Chief Product Officer for AI at Core Scientific. And now I'm excited to hand it over to our first presenter. Tony, are you there?
Yes, great. Thanks very much, David.
Thanks for being on. Take it away.
Yeah, thank you. So today you're going to start things off by looking at the state of the AI landscape. I would say everything from improving clinical outcomes for patients to streamlining supply chains to enhancing customer service interactions. AI is really attacking valuable low-hanging fruit, as it were, in really every industry. Enterprises everywhere are finding these low-hanging fruit in terms of tenable use cases that they can deploy now to start their business transformation. We're showing just a sampling of those here, but we want to impress on our attendees today, those of you listening in, that the reach of attractive use cases hits every industry, including yours, fueled by data that you already have. Now, the question is, how do you go about pressing forward into AI? So first, consider the following. Something that used to be reserved for academia and research is now making its way into every enterprise that wants to deliver better outcomes, better experiences, and mine insights, and even help us communicate with each other in this global economy. But to really tap into the power of AI, many of you will need to train models that are exponentially increasing in complexity, with data sets that are exponentially increasing in size every single day. And in enterprise, time to solution is everything. Model training needs to move at the speed of business, and rapid iteration in the development cycle is essential. And it will take supercomputing scale to accomplish this. This is why every enterprise is becoming or will become a supercomputing enterprise if they not only want to survive, but to thrive. And doing that starts with having the right expertise, the right platform in place, and really taking a infrastructure leadership position to support your data science practitioners and your infrastructure team. So how do we get your team over the finish line? To start, we need to recognize how the experts in your organization come together to enable the development of AI applications. Starting with data scientists, we need to arm them with the fastest path to productive experimentation such that they can effortlessly scale and create models, prototypes, iterate on them, and optimize for the use cases at hand, like those that I mentioned earlier. They don't need and shouldn't need to waste time worrying about the underlying platform. They shouldn't have to wrangle code or engineer software to build a usable AI software stack. They shouldn't be doing systems integration work, trying to procure compute resources, for instance. They simply need to access the best pre-built, pre-optimized AI software that lets them focus on creative experimentation. And once they have a proven model that's ready for production, your infrastructure team, led by data engineering and your ML ops team, needs to be able to deliver a data pipeline that supports model development and training at scale, as well as production inference. They're responsible for helping you industrialize or mechanize the AI in a production setting. And your IT management team needs to be able to enable all of this with a proven standard for AI infrastructure that eliminates design complexity, delivers predictable performance at scale, and is easy to manage with familiar tools. So having said all this, there's actually an ugly secret that we need to bring out into the open. So many organizations are doing some remarkable work in AI, as we mentioned, but they're doing it in the total absence of IT involvement. So why is that? I mean, more often than not, your developers couldn't find the resources that they needed in-house. And there's an almost ubiquitous availability of cloud compute in a convenient OpEx model that has made it easy for your teams to stand up what we'd call shadow AI. And the sprawl of shadow AI is continuing right under IT's view in the absence of an AI infrastructure strategy that could be and should be enabling the kind of successes that we shared at the beginning of our session today. Now, forward-leaning agencies and enterprises that want to infuse AI into their endeavors are taking a new look at all this. They realize that running up OpEx in the cloud may not always make sense. And they understand that the right infrastructure strategy can be an enabler for consolidating AI expertise across the organization, standardizing best practices, and accelerating time to solution on the most pressing AI opportunities. This is what we call the AI Center of Excellence. And many teams like yours have used it to democratize access to AI development. Now, I picked on cloud a little bit, but I want to make something clear. This is not a cloud versus on-prem discussion. In fact, both have a useful place in your AI development journey. But I'll also say the cloud is not the AI hammer for every nail. It's a great way to engage in early productive experimentation, enabling your developers to get a fast start with a low barrier to entry, and certainly can support temporal needs as AI development is just starting to get underway. But eventually, through ongoing iteration, once AI models start to get more and more complex, consuming more and more compute resources, and in parallel, the data sets fueling that training get exponentially larger. This is the point at which costs escalate and the effect of data gravity starts to become noticeable. And by this, I mean more time and money is being spent pushing data sets from where they're generated to where the compute resides. The speed bump and the escalation in OpEx is an inflection point at which organizations start to realize that there's a benefit in a fixed cost infrastructure that supports rapid iteration at the lowest cost per training run. And ultimately, when your developers can train models without restriction or fear of budget overrun, they'll build more creative, better applications with the highest predictive accuracy possible in the shortest timeframes possible. So now, once you've come to the conclusion that you need a deterministic performance of a dedicated on-prem infrastructure, you might be faced with an additional question. Is your data center even ready? In this Accenture study, 84% of respondents saw AI as posing an existential threat, as it were, and an opportunity to their future. For that reason, most leaders know that they need to commit to and scale AI. But first, they'll face a fundamental challenge, that being, how do I actually scale AI in a production setting in enterprise? Many organizations want to deploy AI and leverage it for their business transformation, but many find it challenging. A surprising 76% of respondents cited that infrastructure was blocking their AI success. In fact, it posed a bigger challenge than even talent or budget. But these are likely the same organizations that need significant infrastructure to power their AI-infused future. So why is infrastructure so hard? So being able to support a production training environment means designing an architecture that integrates the right balance of compute, storage, and networking along with the right facilities planning discipline to deliver predictable performance. It also means the architecture needs to enable growth as models and data sets grow and as more developers start using the platform. As workload grows, it becomes paramount to ensure that the infrastructure can keep GPU compute resources fed with data. The consequence of having the wrong architecture is the staggering cost impact on data science productivity. The second challenge is the complexity of standing up an environment. Most data scientists want to practice data science, but none of them want to spend their time procuring, integrating, troubleshooting hardware and software, as well as engineering a software stack that needs to be optimized for performance. The complexity of putting it all together can mean months of delay to getting started. And finally, once a platform has been deployed, how will it be supported? How will IT know whether an issue that they encounter stems from storage or compute or networking or drivers or libraries or even the AI framework itself? System downtime means idle data scientists, which can run up your OpEx costs rapidly. So here's what a typical deployment looks like when you consider what's involved in standing up an AI environment and its supporting infrastructure. The blue parts are basically the sweat equity or labor expended by your valuable data science team, spent on stuff other than practicing data science, namely engineering code, wrestling with open source software churn, playing the role of systems integrator. The green is actually the platform CapEx. Too many teams realize that by the time they've stood up the platform that meets the scale and performance demands of their use case, they've wasted months on things that have nothing to do with building better applications. And they've realized too late that the hours of lost productivity have a dramatic cost impact associated with them. We'll come back to this slide a little later. So with this mindset in place, we set out to give AI developers and IT teams the tools and solution they needed to do their most important work. We started with a universally accessible AI software stack developed by NVIDIA engineers and updated monthly to deliver the fastest performance for the most popular ML, machine learning and deep learning frameworks out there. We containerized it in Docker for easy, rapid experimentation, and we optimized it to run flawlessly on the world's first portfolio of AI supercomputers, the DGX systems. These are purpose-built to tackle one problem and one problem only, delivering the fastest time to solution on the most complex AI problems out there. We built this portfolio of supercomputers that could extend AI development from cloud to desk to data center at scale, ensuring that your team could do their most important work on their terms and scale effortlessly in response to demand. So how do these solutions come together? They might, for instance, start with a cloud-hosted environment backed by a GPU, giving your team enough computational power to start rudimentary models, leveraging publicly available frameworks offered by NVIDIA, and maybe some early data sets of manageable size. But depending on training time, the amount of data being moved between storage and compute, this may also be the point at which an on-prem deployment for instance, on one of our DGX stations, as an example, is employed, shared by a data science team. It's very important at this initial juncture that they can quickly engage in fast, productive experimentation, tuning and optimizing their models, collaborating with coworkers. This might involve multiple model development pipelines happening in parallel, maybe using different frameworks or code level optimizations in pursuit of building a model that will eventually yield the best accuracy when moved to production. Now, eventually, with a winner emerging and the need to train using larger data sets, this model will need to be ported to a platform that offers more resources and can support faster training cycle times. Portability of work from the experimentation phase to the production phase is key, and NVIDIA's DGX registry enables effortless mobility of models from the DGX station that I show here in an office setting to a DGX server sitting in a data center. This portability is enabled with no recompiling of code necessary, since all these platforms run on the same software stack. You simply push the container to the station, back to the registry, and then deploy it from there to the DGX1, as I show here. Now, when you're ready for training at scale to further shrink time to solution, that same work can extend to a cluster of DGX2s, as an example. So ultimately, the trained models can be leveraged for inference or on any number of platform or endpoints. Once in a production setting, new real-time data can be used to further refine and evolve the model for even greater accuracy. So now, how do you get to the right infrastructure that can scale the capabilities of these systems? The good news is that we've spent a lot of time figuring this stuff out with some of the world's largest hyperscalers. These are companies that have vast CapEx and OpEx resources and do groundbreaking work that we all benefit from. And through that experience and our partnership with them, we've established some best practices that every organization can employ regardless of their size or embedded expertise. These include carefully designing racks for higher density and power, considering networking between nodes in the cluster, optimizing for very high bandwidth and low latency, especially where multi-system training is involved, looking at 100 gigabit connections between systems, making sure that the storage can support extremely high IOPS with very low latency, as well as the software that it has to be optimized for multi-system cluster-aware training. So when you put all this together, this is where having a proven reference architecture can come in really handy. We took all of that experience and know-how and baked it into an infrastructure design recipe that we call DGX POD. DGX POD is the blueprint on which we built our internal supercomputing infrastructure. We call it DGX Saturn V. And we have enterprise customers around the globe who've deployed this very same design. It's also the blueprint on which AIRI from Pure Storage is based, which we're going to hear about in a moment, which has also been deployed globally. So what does all of this mean for businesses like yours? Now take a look at this picture. This is what Moore's Law gave us. Massive, monolithic, power and space-hungry infrastructure that's inaccessible to most, complex to design, and even harder to maintain and scale. This is what slow compute AI infrastructure looks like. We took all of this and replaced it with this. Same performance, a fraction of the cost, a fraction of the power and space. This is what today's AI data center built on NVIDIA DGX and Pure Storage AIRI looks like. Simplified design, faster deployment, effortless scale, and manageability. Now, remember the TCO slide that I showed earlier? Let's see what happens when you deploy a full stack AI solution purpose-built for AI and an infrastructure based on AIRI from Pure Storage. The non-value-added activities that have nothing to do with data science drop off your timeline, and your time and effort is solely focused on productive experimentation and insights. And because your team has saved a ton of OpEx, your TCO is actually lower than if your team tried to take on the role of stack developer and systems integrator. And you get one very important additional benefit, that being a dramatic compression of your timeline. All the time saved from non-value-added work means the workflow that we talked about executes in a much shorter time frame, which means that you can iterate more, develop better models, drive up accuracy and performance, ultimately delivering a better product or service to your customers. Now is a good time to explore this infrastructure solution closer and learn more about how AIRI from Pure Storage delivers these benefits. And for that, I'll turn it over to Bish. Bish, take it away.
Thanks, Tony. Thank you, everyone. To understand how we arrived with AIRI, let's take a quick trip down the memory lane. In the last 2 years, Pure Storage and NVIDIA have established a proven track record of jointly unleashing AI innovation at lightning speed. Almost 2 years back in March 2018, at the world's most important AI event, NVIDIA GTC, AIRI was first announced. Architected by Pure Storage and NVIDIA, it was the industry's first complete AI-ready infrastructure built to bring AI at scale to all enterprises. We followed that up in May at Accelerate, where we added support for AIRI Mini, bringing AI within the reach of every enterprise, as well as support for Cisco Fabrics. In early 2019, we further extended our partnership with Cisco for AI, launching a converged infrastructure with FlashStack for AI powered by NVIDIA GPUs. And in March of last year, we announced Hyperscale AIRI together with NVIDIA and Mellanox. And this was aimed for pioneering AI enterprises who needed supercomputing capabilities. This level of innovation is something that many of our competitors have struggled to match. And to understand why some of the legacy vendors have struggled in bringing AI at scale to the customers, let's look at a couple of challenges, or I would say underlying problems. The first major challenge for customers is that data is often stuck in infrastructure complexities and sprawling silos. And guess what? The legacy storage industry is largely to blame for that. They offer customers these numerous data silos, you have the data warehouse appliances, you have the data lakes, you have streaming analytics clusters, and now AI cluster. But wait, there is something else. We often look the need for the right software development platform. The modern DevOps, Docker, Kubernetes, they all need storage. A data scientist developing an AI model on his Jupyter notebook needs a persistent storage as well. While I'm not denying that each of these silos may be useful for their original task, but in today's data first world, where the data in warehouses is also important to drive AI models, and where the data generated by AI models can drive data warehouse analytics, silos are just counterproductive. And data in software dev is out of reach from AI cluster. Data in the warehouse is out of reach from streaming analytics workloads. You get the idea, right? You need multiple times more data for incremental improvements, but data is spread across silos and out of your reach. And by the way, all of these silos are individually growing, and that itself is creating unnecessary complexities in the infrastructure. Now, looking at another challenge, this one more specific to the AI pipelines. Each stage in the AI data pipeline has varying requirements from storage. That includes looking at access pattern, access type, file sizes, concurrency. Let's look at ingest, for example. Here, the access pattern is usually sequential writes. File sizes are usually small with lots of metadata operations. But then you go into the exploration or training, and access pattern is completely the opposite. It's random reads, and the file sizes can vary from small to large files. But what happens when you have trained a model? You need to deploy it, integrate it with your DevOps environment. That brings its own set of requirements for a storage solution. A storage system has to deliver uncompromised performance for all data, irrespective of access types, patterns, from small metadata heavy to large files, from random to sequential access pattern, from low to high concurrency. And for a lot of these legacy storage systems, this is an impossible design point to meet. And that brings us to the key questions. What makes FlashBlade different and such an ideal storage platform for AI? One of the biggest differentiation with FlashBlade is the ability to accelerate your entire AI pipeline. We just discussed all the stages in the AI pipeline. You might have some of your other pipelines, your software development pipelines, and some of the other workloads. All of them can be built on top of FlashBlade. And FlashBlade is the perfect storage system for each of those stages. And here is why. Pure has done to storage what NVIDIA has done to GPU to support modern analytics and AI applications. Just like GPU Direct removes the software overhead and moves data faster to GPU, our Direct Flash removes the software overhead in storage, delivering data faster to GPUs. This is critical for your data-intensive application. FlashBlade is the only storage that delivers a true scale-out architecture for any data at any stage of the data pipeline without bottlenecks or hotspots. The second reason why FlashBlade is ideal is the ability to consolidate data silos and workloads on a single platform and just unifying the data. Shared data is more valuable than just stored data. And FlashBlade offers a single platform which is powerful enough for any application to share their data. How do we do it? Using our Purity software. Purity is the operating system that's specifically written from the ground up to unify the silos. It converges two of the industry-leading standards, the NFS file workloads and the S3 object workloads for modern and cloud-native applications. This allows enterprises to consolidate workloads while leveraging compute resources from CPU to GPUs. And thirdly is scale. While building FlashBlade, scale out was one of the key pillars. But we look at scale out slightly differently. When you add more storage, it has to be simple. It has to be non-disruptive. Why? Because when it comes to analytics and AI, your data is going to grow. It's not a question of if, but rather when. So when your data grows, can you really expect your data scientists to stop developing their applications? Or can you expect your data engineers to stop cleaning and curating the data? That sounds ridiculous. And this is where our scale-out fabric is unique. It's designed to seamlessly extend to 150 blades under a single namespace, meaning your network fabric never goes down. There is no downtime or no maintenance emails from IT. We talked earlier about the unique requirements for each stage of the AI pipeline. What AI teams really want is a shared storage system that can deliver the performance as if the data is stored locally and to do it with cloud-like agility. What they really want is a scale-out data platform that is tuned for the entire pipeline. So no one stage is the bottleneck. And that is the AI Data Hub with FlashBlade. And if we look at a real-world pipeline, this is what it likely looks like today. You ingest and store petabytes of data. The data is then read into the AI pipeline with CPU servers that are responsible for cleaning and labeling the data. Labeling is often done with neural networks that are pre-trained to take a first pass on the data. And once you have that labeled data, data science teams can start taking a subset of data and quickly build models and running their hypothesis. And once the model is developed, it has to be trained on all the data sets. This is where AI at scale infrastructure defines the success or failure of an AI initiative. What FlashBlade does is eliminate the friction from data silos in each of the pipeline stages, all the way from ingestion to inference. Both exploration and training today is done on a GPU-powered servers. With our partnership with NVIDIA, we are empowering data science teams with flexible options of AIRI with all the needed software stack optimized out of the box. So your data science teams have the highest productivity and your IT teams can support the ambitious projects in your organization. Tony mentioned earlier about the AI landscape and how it's growing across industries. Here are some of our success stories. Today, Pure FlashBlade and NVIDIA together have successfully deployed around the globe for AI for various use cases and industries, from healthcare to automotive, from technology to leading government research labs, to financial services companies and hedge funds, to companies delivering area as a service, such as Core Scientific, and we'll hear from Ian very soon. FlashBlade has helped ensure that GPUs are fed and have enabled customers to achieve key business outcomes, be it lowering OpEx costs, improving productivity, achieving faster time to insights, and more. With AIRI, we have removed one of the biggest problems with the do-it-yourself approach, which is an approach full of system bottlenecks. AIRI with Pure FlashBlade and NVIDIA eliminates the data bottlenecks so GPUs are fully utilized, and ultimately the goal is your data scientists are productive. It's tested, it's proven, and it's simple and faster to deploy so that you can significantly reduce your time to insights. To drive the discussion further and to talk more about how Core Scientific can help, let me hand it off to Ian now. Ian, take it away.
Thank you, Bish. Good morning, good afternoon, and even good evening, folks. I noticed there's attendees from Nairobi. It's about 9:30 in the evening. So welcome. I'm Ian. I oversee the AI infrastructure at Core Scientific, and I'm really excited to talk to you about the cloud for data scientists. There we go. So our mission at Core Scientific is to empower data scientists like yourselves to take on the world's toughest challenges. And we're doing that from two angles. One is to provide the latest and greatest AI hardware infrastructure. And then second is to provide the software orchestration and management that data scientists need. And I'll go into more details on all of these. But essentially think of getting the ease of the public cloud. So, the products that you might be used to in public cloud with the benefits of co-location. So other than PowerPoint challenges, we'll talk about some of the other challenges that data scientists run into and really build on some of the trends that you've heard earlier from Tony and Vish. So as we've been building out this infrastructure, we've been meeting with a lot of teams. So this is kind of the high-level items that you might run into. The first is managing costs in the public cloud. So we've seen a lot of groups start off maybe in the public cloud, but then once they reach a certain duty cycle or certain amount of GPUs, it really becomes cost prohibitive to keep doing that at scale. The other challenge that we run into is getting, the latest and greatest GPUs from NVIDIA available in a public cloud environment. And I'll talk about that in a little more detail as well. Sometimes you have to be a generation or two behind when you're in the public cloud. I think Tony and Bish hinted on GPU saturation already. This is really critical. If you're going to invest in GPUs, you want to make sure that you can really saturate the cards and get the most ROI from your investment. But there are good things in the cloud. They have really great tooling. It's really easy to just go up into Colab, SageMaker, etc., and get to work without having to think about infrastructure. And there's also the ability to do on-demand scale and to pay on an OpEx-based model. So those are some of the positive things from the cloud. On-premise, conversely, we've met a lot of teams that struggle managing a cluster of servers for AI. They have challenges sizing the right infrastructure, so they either buy too much gear or they buy too little gear, and then when they have peak workloads, they're not sure how to do that. And then obviously there's the whole CapEx investment needed, as well as having AI operations to actually manage this gear. But on premise, you absolutely can get the latest and greatest GPU. So that's kind of the upside on the on-premise, as well as the financial benefits that Tony alluded to. So let's talk about some of these in more details. The first is just the phenomenal work that NVIDIA is doing, pushing the innovation on GPUs. And this is just a rough timeline that shows the releases from 2012 to this year. And you can see that these new generation GPUs are coming out at a significant clip. But you could also see that there's a delay from the GPU generations being released before they're available on the public cloud. So this speaks to the point of, if you want the latest and greatest GPU, you will not be able to get that in a public cloud. They unfortunately have to optimize for scale. And so it takes a while for public clouds to have the latest and greatest available. GPU saturation we spoke about as well. This might be a little too technical, but the point that the slide tries to impress on you is that you want to make sure that the data pipeline from the storage all the way through onto the actual silicon of the GPUs accelerated. And so when we partner with Pure Storage, it's important that we have this high-speed interconnect, that we have high-speed throughput to saturate the GPU. And we actually did a exercise with MIT on training a big GAN, which is an enormous network. It was about 100 terabytes of storage. And the first thing the data scientists said was they couldn't believe how saturated the GPUs were. They were basically pegging all the GPUs versus having 100 GPUs that sit at 15% utilization. So they were super impressed by that capability of the AIRI infrastructure. The other challenge I spoke about earlier is once you move on-prem, what happens to my highly available control plane? Where's my Azure ML, my Azure Marketplace, my SageMaker, my Colab? And so there's this software gap that needs to be filled to give you the same experience that you used in the public cloud, but on a on-prem or colo deployment. And then we spoke about the staffing as well. As companies have become used to outsourcing essentially DevOps to the public cloud, when they do bring infrastructure on-prem, they have this gap to manage said infrastructure. So I wanted to introduce the cloud for data scientists, which is 3 layers. The first layer is what we call PLEXUS. It's our software stack that tries to give you the same experience that you're used to in the public cloud. The second layer is giving you access to the latest and greatest AI infrastructure. And the third layer is making that available where your data lakes are. It's remarkable that only 20% of workloads are in the public cloud, which means about 80% of workloads are still running in co-location and on-premise configurations and deployments. So this is what we call PLEXUS. So PLEXUS is essentially a miniature version of a public cloud software stack that gives you access to a web-based access just like you used to with public cloud, to access your data science infrastructure. It has a equivalent of a marketplace or an app portal that we've integrated with NVIDIA's Inception partners. So all of the data analytics, GPU accelerator software is available for you to run. We also integrated with the NVIDIA GPU Cloud, NGC, and that gives you access to all the phenomenal work that Tony and team are doing to accelerate, whether it's TensorFlow or PyTorch with their latest CUDA versions. So that's kind of the top tier. Beneath that, we have some of the other challenges addressed around scheduling and resource management. We've seen a lot of teams that use AI infrastructure almost like a mainframe where they're taking turns on a calendar who gets to use it. There's also obviously billing if you're using third-party compute. We do workload tuning where we map workloads to infrastructure to make sure you can get the most performance. And then obviously there's the highly available aspects that you don't have to worry about, oh, my AI software is not working this morning because we had a drive failure or et cetera. So a couple of things, and I'll go through this fairly quickly. We support both queued and interactive workloads. So a lot of data scientists want to come up to their portal and say, okay, I want to launch a notebook, PyTorch, MXNet, TensorFlow, and then I would just want to start coding and run my model. And so that's the interactive workloads. We also have data scientists or workloads where you want to run a script and you don't want to necessarily watch it. So we support both those interactive and non-interactive workloads. On a backend, we support both Kubernetes-based control planes or Slurm-based clusters. We have shared access to some of the common data sets. One of our customers coined the term the data swamp, referring to just the mess of a shared storage amongst data scientists and how many copies of ImageNet can you have. And so having a controlled shared access to common data sets is a great win. Building off that, we also support roaming data folders. And so what this means is you're a data scientist, you're working in TensorFlow, you have a training data set, you produce a model. Now you want to load that model into, let's say, OmniSci to do some data visualization. You have this roaming folder that's backed by Pure Storage that goes with you as you move between applications. We also have obviously the ability for data science leads to manage the resources within their groups. That way you can make sure that certain teams don't hog all the resources. We've made it really easy for you to burst into the public cloud. So if you have spike workloads and you have to burst into the cloud, we made that easy. Single pane of glass allows you to run workloads on your infrastructure or potentially burst to the cloud. We have AI models that tune the workloads to the right infrastructure. So based on heuristics that we collect when workloads are running, we'll give you recommendations that say, hey, you should run said workload on this cluster because of A, B, and C. Obviously, there's the 24/7 operation support, which would be similar to being in the public cloud. I spoke about the integration with the Inception partner. So this is a screenshot of our app portal, and you can see some of these partners that are integrated. Fast Data, Bright Light, OmniSci. These are all data analytics or data processing GPU accelerators that you can run on the same infrastructure if you wanted to do so. This screen just shows an example of matching workloads to the hardware infrastructure. So we have the ability to collect heuristics and make sure that if you're optimizing for price or if you're optimizing for performance or both, we have the ability for you to direct your workload to the right infrastructure. So that was just a summary of the software layer. Layer 2 obviously has been addressed by Tony and Bish. This is really getting the right hardware infrastructure underneath the AI software stack. And so we support both FlashStack and Airy. And again, a lot of work has been done by these teams to make sure that the interconnect between the storage and the DGXs are optimized, that the right switches are used. And so it's really makes a large difference to actually have infrastructure designed from the ground up for AI versus trying to shoehorn AI onto a CPU cloud. This just shows the different compute nodes, DGX1, DGX2, Cisco 480MLs that we support. And then the last layer, which is really critical to our solution, is the ability for us to deploy this infrastructure almost as an appliance in one of our data center hosting partners. So you have Equinix Digital Realty, Colovor, Flexential, Markley, or even in some cases on customers' own data centers. So you get your mini AI cloud co-located with your data lakes versus having to ship the data into the cloud or vice versa. We also have our own hosting facility if that made sense for the use cases. And then we offer both dedicated clusters. So if for data privacy reasons, your data cannot leave your cage, we can actually drop an appliance inside your cage. We will manage it. You'll have the same software experience, but then you know that the data from your other applications or line of business pipelines are not leaving your cage. So a real quick summary. So the walk-up tooling and workflows, very similar to what you get in the public cloud, but with the ability to be co-located with your data. Again, that 80% of workloads that are still on-premise or colo. Being able to get the latest GPUs and then being able to utilize said GPUs as efficient as possible. Keeping the OpEx model that you might be used to from a public cloud point of view, and then obviously not charging for egress and ingress fees. So in terms of next steps, we do offer a proof of concept on Airy as a service. This is done through our facility in Atlanta region. And it's really simple for you to try out Airy as a service. We just need a GitHub account. We'll send you a link. You'll be able to log in. And in under 10 seconds, you'll be able to be up and running on Area as a service and get a feel for the infrastructure and the performance gains that said hardware provides. So with that, I'll hand it over to David for Q&A sessions. Thank you very much.
Excellent presentation, Ian, Bish, and Tony. Really cool, really cutting edge stuff you guys are talking about. I've got a link right here to the email that you have on the screen, and I'm just going to paste that into the chat box for everyone out there in the audience. If you have additional questions after this event, or you'd like to ask questions about that evaluation, email purestorage@corescientific.com. And I wanted to drop that out there before we get too far or too close to the end of our event so that you have time to check that out and click on that link. So let's now take some questions from the audience. If you have questions about today's topic, now is the time to get them in. First question that came in is for Tony. Tony, they're asking, what's the best way to get an AI project started, in your opinion?
Sure. Like a lot of things, this is a team sport. We talked about some of the key sources of expertise that kind of need to come together early on in today's session. This is really about a multidisciplinary team that comprises data engineering or ML ops, a business analyst, a data scientist. You got to have kind of a DevOps culture going, obviously, to be able to bring this into fruition. You definitely need like an application developer on the back end. Essentially, work starts with a business analyst, I would say, someone who's very close to the data sets and knows kind of a fundamental problem that your organization is trying to attack, which is worth money to you if you were to solve it, right? Part of that also means having an executive sponsor who cares about that problem and is willing to help you evangelize some early successes. It's great to kind of define that initial use case that's hopefully low-hanging fruit, but still attached to that fundamental business impacting problem that we talked about. I think ambitions at the get-go have to be set very modestly because you want to attack something very simple and then look for repeatability and follow-on use cases that you can attack afterwards once the team has built some muscle memory about going from a problem to a concept to a trained and deployed solution. It's really important at the get-go to understand and review your data, look at where it resides, how it's accessed, how it's cleansed and transformed and labeled such that it can be fed into a training regimen. You do need help from an application developer to work closely with DevOps to build, deploy, and manage the apps that infuse the AI model that your team is working on. And as you move into production, you need to ensure that there's integration between the inference model running in production and new operational data that needs to come in and could even help drive things like model retraining, such that over time you're monitoring the accuracy of the model, how it's performing, whether it's drifting, whether you need to do subsequent training runs, that kind of thing. But that's kind of a life cycle of how you might approach this. And again, setting initial expectations modestly and looking for a fairly simplistic use case that's worth money to you is obviously the best way to start. If you do this one well, it will create a flywheel of success because the team will develop muscle memory around it and be able to do it, attack more use cases faster and more complex ones subsequently.
Great advice. Great advice. Follow-up question to that: should shared infrastructure be used for these types of AI workloads?
Great question. This really depends on your organization's size and complexity. And depending on how big your organization is, you might find that there are in fact multiple pockets of AI development that are spawning. This is kind of what I called shadow AI, right? It's the sprawl of independent developer teams that are doing their own thing, procuring their own resources, maybe running up costs on a credit card or in compute cycles that they can get their hands on quite easily. So each of these might be silos attacking a different business unit's problem, each looking for infrastructure, and certainly cloud is a great way for them to do that, but it's running up your costs, right? Especially if you sit more on the IT and facilities side of this. Now, individually, each one of these projects, kind of these shadow AIs, might not have critical mass to justify their own appliance. and they might not even have budget to do what they really need to do. So this is where IT can really help the CIO and the CFO get ahead of this challenge by proactively creating that center of excellence thing that I mentioned, where you can have a common shared infrastructure that multiple teams can leverage. And with technology like Kubernetes, for instance, running on our NVIDIA DGX platforms, there's now a better approach to accessing and managing those computing resources while ensuring the maximized utilization of your investment. So you can basically, if you follow this approach and you look for all these pockets or silos of shadow AI, you can basically justify creating your own private machine learning cloud that's elastic in a way in its ability to offer capacity to all of your developers, no matter where they sit in the organization and the lines of business that they support, and at the same time driving down the cost per run to the lowest possible.
Very nice, very nice, excellent. All right, great insight and advice there. Let's see, another question that came in. This one's for you, Bish. Can you consolidate multiple analytics and AI workloads on FlashBlade?
Great question. You can, and that's what a lot of our customers really like FlashBlade for. The fact that you not only can consolidate a lot of these workloads, you don't need to tune the infrastructure specifically for specific workloads. Irrespective of whatever the demands of your workloads are from a performance perspective, the system is ready to do that. And the scalability just gives the customers the flexibility to start small and then grow as their workloads and demands grow. And as you scale the FlashBlade environment, it adds storage, performance, and capacity in a linear manner. So short answer, yes, absolutely.
Okay, that's great to hear. Great to know that there's that kind of flexibility. Oh, can you tell us what are some of the other workloads that you can run on a FlashBlade?
So beyond the different AI workloads, the customers, some of the top use cases are modern analytics, think log analytics, your Splunk Smart Store, Vertica Eon Mode, as well as Elastic. And a lot of our customers also love FlashBlade for rapid restore use cases. Rather than storing the data on a traditional backup device, having it on a FlashBlade so that they can restore the data much faster. And you could run all of these workloads simultaneously along with your AI workloads as well on a single platform.
Oh, that's very nice to know that there's multiple use cases for the same FlashBlade solution. Um, Excellent, excellent. All right, let's see. Next question's for you, Ian. I know a lot of companies out there, they think that public cloud is kind of the common hammer for every problem, if every problem looks like a nail. But what about a Core's AI as a service? How does that compare and contrast with public cloud?
Great question. So we're trying not to go after customers that are in the public cloud. The good news is a lot of the Fortune 500 companies have been around before the cloud, and so they're the 80% workloads that exist in co-location or on-premise facilities. And so what we're trying to do is, instead of saying, hey, take your data to the cloud, we're saying, what if we bring the cloud to your data? And that's really how we differentiate. We're trying to take the best of the public cloud, bring that to you on premise, versus trying to figure out how you move your data in and out of the cloud.
Very nice, very nice. And then before we go, I wanted to ask you again, could you just kind of review with us again, what could we do to get started, to get a sneak peek or a trial of the Core AI as a service solution? I know you went over that a little bit in the previous slide.
Sure. So the first thing is to email purestorage@corescientific.com. The actual process once your POC is approved is the simple GitHub login, and your data scientist would then click on an icon and will be up and running on a area as a service infrastructure under 10 seconds. They'll be dropped into a notebook environment similar to Google Colab. And then you'll be able to upload your training data sets, start running your models, and kind of get a feel for the performance that this infrastructure provides.
Very nice. Sounds fast and easy to do to get access to something that this sounds just so incredibly fast and incredibly cutting edge. Well,
Right.
Tony, Ian, and Bish, it's been really great having you on the event today. Thank you so much.
Great, thank you.
Thank you.
Before we
for
go,
having me.
thank you, everyone. Before we go, I want to award our Amazon $300 gift card that is going out to Josh Rhodes from Kansas. Congratulations, Josh Rhodes from Kansas. We'll reach out to you to deliver that gift card. I want to remind everyone that I put the email address there, purestorage@corescientific.com, in the chat. You can just copy it from there and contact Core Scientific to get your evaluation or POC set up for the AI as a service solution. Thank you to Pure Storage. Thank you to NVIDIA and Core Scientific for supporting today's event. And thank you to our audience. We'll see you next time. Have a great day.